Afternoon and good evening to all those who have joined us from across the world. And I, ISTT and IWA, welcome you all to our webinar titled Introduction to Nordic Technologies and the ISTT, organized jointly with the International Society for Trenchless Technology. Now, moving forward, I would like to highlight the housekeeping rules for all our participants. I would like to mention that this webinar is recorded and it will be made available on our IWA Connect Plus platform for our members and the IWA official website with relevant information, including the presentation. The speakers are responsible for securing copyright permission. And I would also like to highlight that the opinions, conclusions, or recommendations contained in the presentations are the sole responsibility of the speaker and do not necessarily reflect IWA opinion. For all the participants, this is how the screen would look like. I would request everyone to use the chat box to introduce themselves and where they're joining us today, and use the Q&A box to mention their questions to the panelists. And we will try to answer most of them during the discussion. But due to time constraint, we won't be able to cover all of them. Now, coming to today's agenda of the webinar, I would quickly like to mention that the introduction would be given by our moderator for today, Andreas Gross, who is also a member of ISTT's working group on strategic alliances based out of Germany. And then we will have a speaker presentation titled Introduction to the Scope and Activities of ISTT, and the overview of Trenchless Technologies by our speaker, Ian Naismith, who is the chair of UK Society for Trenchless Technology, which will be followed up by a live Q&A session from the audience and the closing remarks. So without further ado, I would like to welcome Andreas Gross to take the webinar forward.
Thank you very much, Afia. Good morning, good afternoon, good evening, everyone, and welcome. My name is Andreas Groß, and I'm pleased to be moderating today's webinar. Thank you all for joining us for this important session, which is the first joint webinar hosted under this new cooperation between the International Water Association and the International Society for Trenchless Technology. As many of you may know, IWA and ISTT entered into an agreement in 2025 with the shared goal of helping to mainstream trenchless technologies in the planning and construction of water, wastewater, and stormwater infrastructure, particularly among utilities and service providers. This collaboration is especially relevant at a time when challenges such as water loss and the need for improved underground asset management are increasingly urgent priorities across the sector. Today's webinar is designed as an introductory session. We will provide you with an overview of who is the ISTT and its role globally, how the condition of existing underground infrastructure can be inspected and assessed, and how pipelines and underground assets can be rehabilitated or installed using no-dig trenchless methods. This session also marks the start of a broader webinar series. Additional webinars are planned to explore specific topics in greater technical depth in the coming months. It is my great pleasure to introduce today's speaker, Dr. Ian Naismith, who brings exceptional expertise and extensive practical and academic experience in this field. Dr. Naismith is a leading member of the International Society for Trenchless Technology. He chairs the UK Society for Trenchless Technology and serves as chair of the ISTT Technical and Education Committee. He is also a senior research fellow at IKT, the Institute for Underground Infrastructure. Ian, thank you for being with us today. We are very pleased to have you. And with that, I would like to hand over to you for the presentation.
Thank you very much. Afi, if I could take the screen, which I believe I can.
Yes, Ian.
There now. Okay. A quick correction, I'm actually the chair of the Technical Education Committee of the UK STT, and I'm a member of the Technical Education Committee of ISTT. But anyway, so good day, everybody, wherever you are and whatever time zone you're in. And I've split this presentation into two parts. I'm beginning with what is trenchless and also what is the ISTT? And then I move on to an overview of the various trenchless technologies. Now, I'd like to start with explaining a question that I was once asked by a manager of a water utility. And he said to me, Ian, what does a utility network owner actually own? And the answer is it's a linear hole in the ground connected at intervals to the surface by shafts and through which the utility conveys its product by various means. So it's got to maintain sufficient transmission for the product or the waste that they're carrying. And to do that, you've got to keep this hole open. But most networks are less than 100 years old, and most products perhaps only have an expected life of 50 to 100 years. But we've got to do this indefinitely, over thousands of years. Roman aqueducts and sewers being a case in point. So when we look at an urban or indeed a rural environment, the things which allow us to have this civilization relate very much to the utilities that we must connect. And so the first thing I would say about the ISTT is we are a society for all utilities, not just water. So it's gas and district heating, it's electricity, water, wastewater, communications, and let's not forget urban drainage. And when you look under the ground, you will find a vast array of pipes laid out, as most of you will know, not normally looking as neat as this does in our diagram. By the way, these diagrams are on the ISTT website if you wish to use them. It's a real mixture down there. We don't know what is there. We don't necessarily where it is. And ideally, we don't want to have to dig it up because our conventional method of dealing with it has been open cut, where we excavate a trench big enough for humans to go inside to do the task. In this case, this illustration is laying some new sewer pipe and manholes, and it causes disruption. The role of trenchless in this instance is to reduce this. So with trenchless, we're looking to have a launch point and a receiving point for whatever exercise or technology we are using that minimizes this amount of disruption that is going to take place. And so what we then have to consider is what are all these technologies that we are calling trenchless? And as a result of decades of work at the ISTT, we've come up with a sort of breakdown of what we consider to be trenchless. So when we look at trenchless, we see that, first of all, it's about new installation. It's about trying to put either new mains or connections property in without having to disrupt the surface. We then have to consider how do we keep all this maintained over the long term? And we call this rehabilitation. That's the title it falls under for us. And there's three elements. We're going to repair localized issues. We're going to renovate as we need to keep it, to extend the life. But at some point, we're going to have to replace. So those are the three areas of rehabilitation. But in order to be able to decide where we're going to install, and in order to be able to decide how we're going to rehabilitate, we need to understand the condition of our asset. How is it deteriorating? What are the problems that we've got to address? And we also need to understand what we call site investigation, which is perhaps where we want to access it or where we want to drive a new pipe through. We have to decide what's the safest route. We have to decide what's the best technique. So these are the three areas of trenchless technology. Now, there are a number of advantages or reasons for using trenchless over open cut. So when we look at this, one of the most obvious ones, which is most frequently cited for the urban situation, is reduced disruption. So traffic, pedestrians, businesses, access to people's buildings, minimizing the disruption to other utilities whilst we're doing our work, and also not interrupting drainage, because cutting trenches can interrupt natural drainage processes within the soil. Now, a customer services director from one major utility came to one of our events to present, and she started off by saying, "Guys, I love you." And the reason, she said, was because whenever her company uses Trenchless, she gets fewer complaints from customers that her team have to deal with. But another bigger important aspect of this is health and safety. When we dig trenches, when we put people in the ground, we risk the health of staff, and we open up a risk for the public accessing those holes that we have dug. And then again, moving on from that, we've got the whole issue of environmental damage, air pollution, noise pollution, the waste that comes from excavating. And I've got tree root damage here as well. Increasingly, it's not just the underground, it's the trees that we're interested in. The trees' roots are underground as well. Everybody wants trees for human well-being, and also they help with climate change and with dealing with rainfall. And so we want to minimize damage to those. All of this can reduce carbon footprint with less road opening, less traffic congestion, reuse of infrastructure, less replacement. And from a utility perspective as well, apart from the complaints, it's the costs. So as a generalization, it will vary, is that using Trenchless may reduce project costs. It may be quicker. If you've got to pay for road rental, we don't have to rent the roads. And it can also we don't have to deal with reinstatement of the surface, and perhaps it reduces compensation claims. So there's a range of advantages to Trenchless. And this is one of the other aspects of the society, is trying to make these known, but also to provide the evidence for this. And you will find all of these listed on our website. So, what about the society? So, ISTT is essentially the umbrella organization for a group of 28 national societies. We're spread across the whole of North and South America, very heavily concentrated in Europe, down through China, through to Australasia. And you may have, if you haven't come across the societies, you may well have come across events titled Trenchless or No Dig. And these events, which are usually exhibitions and conferences, invariably have either the ISTT and one or more of the national societies involved with them. And that is not to say that Trenchless is not used in all of the other countries. These are where there's been sufficient interest to form a national society. And they come together under the ISTT, and our secretariat operates out of Australia and Japan. So, if I go on to just mention ISTT's objectives, this helps you to understand the society. It's about advancing the science and practice of technology, Trenchless technology, and it's for the public benefit. And it's about promoting education and training for the public benefit. So although our membership includes the utilities, the consulting engineers, the contractors, the distributors, the manufacturers, we are not a society for any one group like that. Perhaps it's a bit like IWA. We bring everybody involved in Trenchless together in order to further the application of Trenchless for the public benefit. And the public benefit comes from all of those benefits and advantages I've just mentioned. And just by way of further illustration, we have an annual event, and this is the Council of the UK, of the ISTT, with all of the, or most of the national societies represented. So we're about educating, passing on information. And here I would like to just highlight our website. And on it, perhaps one of the most important areas is Trenchless Technology. This is a very, very large web page. And this web page has about 120 plus technologies and sub-technologies listed on it. under the headings New Installation, Rehabilitation and Investigation. Now, one thing I would say is there's many considerations when you've got a project involving underground utilities. What's its purpose? What's the soil type? What's the pipe material, the diameters, diameter changes, depth? Is it a precise gradient that we need? There are multiple technologies, multiple products, and ideally your average network owner and their consulting engineers should have available to them a selection matrix and tools to help them review across what is available, a number of options, and to find what might be the best option for them. But what I've quite often hear people say to me, Ian, it's all very well you telling us there are all these technologies, but we're in a bit of a remote location, we've got a relatively small supply chain, we're a bit dependent upon what they can give us. I would turn that round by saying, if you have looked across the technologies, if you find the one which you feel is the best and you have a program of work, then generally the supply chain will bend over backwards to provide that for you. So it's a case of utilities potentially becoming more informed customers, and potentially this Trenchless page enables you to do that. So you can click on any of the technologies and you get a description and usually a diagram. And the recent developments on the website, we're gradually populating which of the corporate members can do each technology. So it's an easy link to talk to people who can provide it. And also technical papers from our archive of some 2,000 papers that relate to that. To make it a bit easier, we've got an AI assistant who will listen to you and speak to you in a whole variety of languages. And so this brings me on neatly into the second part of this presentation, which is about the Trenchless technologies. So we have, as I mentioned before, site investigation, which is split. We split into asset condition and site investigation. We have the three types of rehabilitation, and we have the new installation. I'll start with the asset condition assessment, and basically we are able to do this from within the pipe and also from the surface. So when it comes to condition assessment, and throughout the rest of the presentation, I've just cut and pasted the relevant button off our Trenchless Technologies webpage, so it's easy to relate to where you will find the relevant information. So if we know condition and we understand deterioration rates, it helps us to make decisions and to financially plan for maintenance, repair, rehab, and replacement. We can do this periodically, we can do this continuously, or I think what is coming along, autonomously. If we're going to keep these pipes open for the next couple of thousand years, we will be moving to a position where autonomous robots will be helping us to make these pipes last longer. For condition assessment, we can use visual methods, we can look at structural condition, and we can also use operational performance to assess the status of the pipe. So we'll have a quick look at those. So when it comes to visual, we've got a whole lot of different sensors which can create visual impressions for us, but we need platforms, a whole variety of them, in order to deliver them. We can fly them, walk them, crawl them, float them, or dive them through pipework. That's fairly active, or we can push them, or they can be pushed by the flow of liquid. We can drag them, or they can be dragged by a parachute along the line of the pipe when it's flowing, or we can have fixed sensors. And just a brief mention here as well. This gives a bit of a feel. Where we've got man access chambers, these things can avoid the need for man access. Apart from the reduction in the number of people, it's also the fact that we haven't got to create a safe environment for a human to enter, because the drones do not need that. So perhaps the most commonly we all know of is crawler CCTV for visual inspection. And this has been interesting because it's been at the forefront of AI for this industry, with the use of artificial intelligence to interpret the visual signs and to classify the damage. And this has been going on for some years now. And another recent development, which is probably of great interest, is the advent of the pole zoom camera. So when you have to open up and look down into your asset for some reason, and you have the ability to look up and downstream, a zoom camera on the end of a pole allows you to look upstream and downstream. It allows you to focus your way up and see the tree roots and the leaks and the local wildlife. And this is starting to be used as just a routine measure for getting more data. So moving on from the visual, we've then got structural condition assessment. And under there, you will find that we have separated out into ways of measuring wall thickness, ways of measuring the structural response of the pipe, and also external void detection. So again, there's multiple methods. One thing I would just say, at the UK STT, we have a group called the New to Trenchless Network, which is our equivalent of young professionals, but we make it for anybody of any age for learning about this. And we normally divide the 3 areas of trenches into 3 2-hour presentations, 6 hours. So I'm trying to do it in about 20 minutes to touch on that. So I cannot explain all of the technologies, but the information is available for you if you would like to know more on our website. So with wall thickness, electromagnetic, acoustic, infrared, we can whack the wall using impact methods, and nuclear would be things like X-ray, etc. And so an example would be a smart pig with a magnetic sensor in it going through and say detecting changes in wall thickness. We can use various gauges, etc., to monitor structural change within the pipework. And external voids are extremely important. We often just think it's the pipe. It's not. It's the pipe and soil complex. The soil is supporting the pipe. And if there are voids in it caused by infiltration, exfiltration, or whatever, it's an issue. And so we have to have methods of discovering that. And so the final of the 3 areas is operational performance assessment. And with this, we've got things like infiltration and inflow within gravity pipes, and we've got things like leak detection from pressure pipes, from gases, from water, etc. Again, a whole range of technologies, including some fairly basic and potentially seen as old-fashioned smoke detection as an option. And with leak detection, things like looking for the leak signature. And I've put this slide in just to illustrate another method, which is using a small parachute here to pull a sensor through the pipe using the water. And so this is being done without needing to switch off the supply. If we basically put all of these together, we are generating data sets on condition. And these are increasingly being used to as a basis for AI. So things like overflow detection, storm sewer overflows, artificial intelligence monitoring those and identifying where there are issues. So all of this is about generating good data, which AI companies can then utilize to give us new tools. So I'm going to move on to the generation of information about the site. We divide that into 2, asset location and asset environment. We want to know where the pipes are, but we also want to know what the ground conditions are around them. So with asset location, just a bit of an example here, and I think 1 or 2 people on the call may recognize this because it is their picture. This is a drone delivered LiDAR model with GPS of a sewer pipe, and it's showing the 3 dimensions, its location. Here is what was recorded on the utilities map, and here is the actual location that has been discovered. Quite important if you're deciding where you are going to dig. But also what we want to know is lengths of pipe of different pipe materials and changes in diameter. And in this case, it found an unexpected small diameter brick section right in the middle. I believe it was possibly considered to be repair of bomb damage from the Second World War. But there's a whole variety of ways that we can also trace a pipe from, or trace from within the pipe. There's sonde, impress signals, various internal survey techniques, and again, the smoke and dye testing. You will find when you look at our website and when you see my presentation, some of the some of the technologies get repeated because they're applicable for different purposes. And so just to give an example here with the sonde, we're using sonar retrieval at the receiver at the surface, and we're able to monitor where the pipe is, or we can be able to monitor perhaps a piece of equipment that we really want to know its location as we're going ahead. So that was from within the pipe, and we're proceeding from left to right there. If we then look at outside the pipe, it's the things like ground penetrating radar and seismic and sonar techniques. Fairly well known and understood, but it all helps us to build us a picture, not only of where the pipes are, but also where what is going on around the pipes, which again brings me on now to asset environment. If we look at asset environment, we've got four major areas that we use. My mistake, go forward again. There we go. It's groundwater monitoring, thermal environment, electromagnetic environment, and ground investigation. Again, a reminder, you can click on any of these to get more information. But if we look at the ground investigation, it's things like geophysical surveys, geochemical surveys, and soil sampling to understand the soil. When it comes to the magnetic environment, there's a number of ways using resistivity meters, etc., and probes to determine what is going on. And here, obviously, if we were looking for somewhere to lay a new utility, we'd probably be looking to go here through the clay area. And then when it comes to the thermal or environment and infrared scanning, okay, this is not strictly underground. This is an image of, I think, looking at leak detection at the side of a road, but it gives you the impression of what thermal imaging can assist us with. And the final of the four methods, really, of looking at the asset environment is groundwater. Now, groundwater is incredibly important, particularly its depth. It helps make decisions about design and construction. And its quality can also give us some indication about what the long-term performance of our pipe might be, particularly if it's, say, an aggressive water. And let's not forget, it's not just rainfall. We're also looking here at saline intrusion. So we're getting literally groundwater that appears twice a day in some coastal locations. Groundwater depth, therefore, is quite significant. And the behavior over the annual cycle of groundwater helps us make decisions about things like the best time to rehabilitate, which allows me to move neatly on into the rehabilitation. So rehabilitation, we have repair, structural and non-structural. We've got renovation, upgrades to structures, and we have replacement of a new pipe or the functional equivalent along the same alignment as the existing pipe. Now, with repair, structural and non-structural. Structural would be where there's a collapse. Non-structural might be where there's a leak that we wish to resolve or an infiltration. And with renovation, we're basically upgrading. So it could be that we're extending the life by structurally or trying to give it a little bit more strength, or it could be that perhaps we're putting in a corrosion, replacing an anti-corrosion layer on the inside to update the pipe and to extend its life. And the interesting thing to see is just how long can we do this over the next hundreds of years with the pipework that we've already got. And with the replacement, we really want a brand new pipe or the functional equivalent thereof, but along the same line. So if we're going to put a second pipe in or alongside it, that's new installation. But if we're going to just replace what is there trenchlessly, that is replacement for us. So when it comes to repair, let's start with the non-structural. So something like dealing with infiltration into a sewer. There's various grouting methods. These are very catch-all titles. You may find a lot more detail and a lot more different applications for them within the information that's available on the site. I've just picked out this one here as joint grouting. So here we've got a void around a joint that we want to fix. So in goes a packer, and it's inflated either end to block the pipe we then put through a grout, and that goes out into the void, fills it, and then when cured, we can remove the packer. And hopefully, therefore, the problem is resolved. And we can do the same thing here with a different shape packer to do a lateral connection. When it comes to the structural repair, there are a range of possibilities. And one that I picked out just here, if as an example, is cured in place patch repair. So here, they're wrapping a long strip of felt around a packer. It's been impregnated with a resin that is not yet cured. It is inserted into the pipe to the point where the break is, that is, we want to fix. The packer inflates, and we then await the curing of the patch, and then the packer can be deflated and removed. And we're left with essentially a new section of pipe here, which is resolving the issue. This can be used for non-structural things like leaks, or it can be used structurally, but the patch has to be designed accordingly. We can also use these for lateral junction repairs. This is an example of a piece of felt, a sock which has been designed or shaped to fit into a lateral connection. It hasn't been impregnated yet with felt with resin, but this shows a cutaway version of what you have after you've installed it and removed the packer. Again, a new piece of pipe dealing with a joint. It's a sort of similar approach to grouting, only in this case we're creating a piece of pipe rather than pumping in the grout. So we've looked at repair. I'm just moving on now to renovation. And with renovation, this is where we are extending the life. And there's a couple of ways of doing it. One of which is with a loose fit or a close fit lining. So when it comes to loose fit, this is where we, for example, with continuous slip lining, we pull in a new pipe which is of a smaller diameter than the existing one. So it's the existing pipe remains where it is, but a new pipe comes through. Obviously, there may be a reduction in, or will be a reduction in cross section. This can be done either continuously, or here's another approach, which is we do it segmentally, where sections of pipe are lowered, and then they are screwed, fixed together, and they are inserted one at a time from one end and pushed through the pipe. There's been a lot of innovation with trenchless, and one of the reasons we've realized why some people are a bit reluctant to adopt it is they think it's a bit innovative, it's a bit risky. It could be that the whole trenchless industry has been too good at coming up with new ideas continuously, but there are many well tried and tested. And if you're interested in a technique, you can usually find, and we hope the ISTT website will help you find, either academics or consulting engineers or contractors or even manufacturers who could give you some advice about that. So renovation moves on into close fit, where we have cured in place. This is like the patch, only it is a continuous line of a carrier material, felt impregnated, which is installed by various means and then is cured. And you might recognize that this is the location I previously showed you. And here we see a new liner going through where this join was with the replacement brick pipe for that apparent bomb damage. A lot of the rest of them rely upon the flexibility of plastic. And you can squeeze down a plastic pipe to a smaller diameter, pull it in, and then allow it to reform and to expand. Or, as in this case, you can fold the plastic pipe up, drag it through, and then inflate it. And there's spiral wound methods and others melting in place, which can be utilized. As I said, I can't cover all of the technologies today. I want to give you a flavor for the different types and maybe to help you understand why we've grouped them in the way that we have on the ISTT's website. And then we have what are called surface applied linings. This is where either they're sprayed on or they can be manually applied, or you can go in and you can bolt together panels, new panels on the inner surface. And one example here would be a cement mortar lining where we're bringing through a spinning head, and the vortex sprays the mortar or the polymeric coating onto the internal surface of the pipe. These can be structural or they can be for anti-corrosion. And so with the replacement, we have a number of ways that we can replace existing pipes. We can burst them, literally shatter them and pull a new pipe through and leave the pieces in the ground. We can split them and drag in a new pipe behind, again, leaving them in the ground. So this would be pipe bursting, pipe splitting. And we can do things like pipe extraction, where we literally pull the old pipe out and pull in a new one. Good example would be a lead service pipe. We pull out the lead and we pull in a brand new service pipe behind it. On to the final of the three technologies, which is new installation. Here, it's a variety of ways in which we can stop digging up and we can install as much as possible by creating the holes and pulling things in, or by pushing the pipe in as we create the holes. So a very common one is horizontal directional drilling, where we use a drilling fluid to support the use of a spinning drill head, which can be directed and which will therefore cut a new hole, and it can be used very extensively up to quite large diameters. Another example would be pipe jacking, a bit like the segmental lining I was just showing before, only in this case we are actually combining the segments.
I think we just lost Ian. Andreas, can you contact him? Because I can see him here.
Yeah, I can see him as well. I will
Yeah.
try to get a hold of him.
Sure.
What happened?
Thank you. Hi, Ian.
Hello?
Can you hear us? We lost you in the middle.
Well, I suddenly had a message that came up saying recording in progress, and it then
Okay.
cancelled my audio.
Okay.
When did you stop hearing me?
No, I think the last slide, the new installation slide.
Yeah.
Yes, you're on this one. Okay, then.
Yeah.
Was it this one that the previous one you missed me on?
Your screen is not shared. Can you share it again, please?
Yes, something odd happened there.
Okay. No worries.
And now I am not seeing. Actually, tell you what. Yeah, I just simply had a strange message came up, and then I don't seem to be able to access. Here we go.
Yeah. Do you want me to share or can you
Right,
share?
and share. Okay, I've now got it back, and screen to and share. How's that? Are you back again?
Yeah, we
Yeah,
can.
can see it now again. Yeah.
Okay, apologies. So was this the slide we got to, new installation?
Yes.
Yes.
Please continue. Thank you.
And you'd heard me explain this one, had you, or not?
I think you can explain this part. Yeah.
Okay, I'll start again on this one. This is new installation, and we're starting up here with the horizontal directional drilling, which is the most popular, perhaps, of the methods, which allows you to use a slurry in combination with a spinning head to work your way through and direct the boring of a hole through the ground. A second option is pipe jacking, where, a bit like the previous method that I showed you for segmental lining, we are combining a tunneling head with segments of pipe which follow it into the ground and are pushed in behind the head. And then we have auger boring, which is another method whereby a cutting head is linked with an auger and it brings the soil back out of where we are cutting. If I move on to the ramming and impact methods, we have pipe ramming, which is where, instead of actually having a tunneling head, we're pushing pipe in and then the soil is contained within it and is removed. And impact molding, where basically a mole is gradually forced through the ground and creates the hole from one side, from one pit to the next. And what I would like to finish on is keyhole drilling as an example, because it also brings in potholing and also brings together some of the technologies and the ideas. So here we have a house, a garden, and out here at the road, we're using keyhole drilling, potholing rather. What's being done is, rather than disturb the entire road, is a small piece of the road is cut out and removed. We use various techniques like vacuum excavation to go down and to create a pit into which a keyhole drilling machine can be inserted. That drilling machine can then cut a hole all the way to the property. Along the way, we have yet another guy tracking its progress so we can see where it's got to. You then attach the new pipe from the property and you can draw it back. And what you can do then to finish the whole thing off, having removed the keyhole drilling machine, is we can use long handle tools. And this is another method, this sort of potholing method. This is not so much no dig as low dig. We are interested in low dig technologies. And what we're starting to see is a lot of long handle tools, really developed perhaps for the gas industry, but of interest to other industries as well, or other sectors, using long handle tools down a small hole to effect a connection. So this sort of brings all of the technologies together. And as a summary, hopefully you've got a very brief understanding of the society and who we are. I hope you can go away with a clear understanding of new installation, rehabilitation, and site investigation and assessment, that these are the technologies. And what we're seeing now is a lot of AI coming in, and there's a lot of innovation across all of this continually going on. I hope you've got a clearer idea of some of the benefits and also the resources that are now available from the International Society. And we look forward to getting your feedback and to hear what else you would like to know about from the Society, and perhaps how your thoughts about how the IWA and the ISTT can work together going forward. Apologies for the slight problem halfway through. Something happened to the projection. And thank you. Over to you, Andreas, I think.
Ian, thank you so much for your presentation. I think this was very informative, giving a first overview of our ISTT and Trenchless Technologies. We have a couple of questions that came in. One from eFeed asking, can Trenchless technology be applied to all kinds of soil, including sand and silt?
And I think the answer is yes, because actually quite a few of those technologies which I have shown you are best applied to soft materials. You would need something which, as it goes along, is opening and holding the pipe, the hole in the ground that you're creating, open. And we go right through to the more difficult stuff with different types of drilling heads and tunneling equipment. You can get through very hard ground as well. So if that answers the question.
There was actually also a follow-up question by Evie asking if it is possible to continue trenching when there is a rock encountered in the path of the pipe, or if there is rocky basalt grounds, basically.
Well, that's one of the reasons why if you like, the site investigation is very important beforehand. If you're dealing with an existing pipe, you're okay, but if you're doing new lay, it is particularly important to have gone through that exercise. And yes, things will be discovered as you go along. It may sometimes be necessary to reroute if it is just not possible to get through. But what you may have to do with a larger project, therefore, is to consider a variety of methods. There will be cases where you have to excavate. There will be cases where you can do it entirely trenchless. There will be cases where you could put the two together. And you never quite know what will be the unexpected as you go through. So it goes right back to this, our focus on site investigation. Do what you can to do that, to really understand where you're planning to put your pipe.
There is also a question coming from Manish talking about condition assessment and water supply pipes. He is looking for a solution to basically identify and locate a leak on a water supply pipeline. What would you recommend to him, Ian? Ian, you're still there?
Yeah, I think
Oh
he's.
yeah, he's coming back. I think we lost you for a second. Did you still hear our question, Ian? It was regarding a water supply pipe. Manish is basically asking how can he identify the exact location of a leak on a water supply pipeline?
It depends, obviously, on the diameter of the pipe and the technology that you can use, and also whether you can. With one of the things with dealing with a water pipe, some of the technologies are a little bit limited because of materials in contact with drinking water, but there are a range of possibilities. And without knowing anything more about the particular pipe, it's difficult to say what the solution would be. But in our resources, on our resources tab, the access to the papers of the ISTT, by searching that, you may well be able to find the answer, or looking to find a company. I'm assuming that he's from a utility, and it's also worth speaking to other utilities in your area if they have tried these sorts of methods. So I can't recommend any one particular method. There are a variety of them available, both from within the pipe and externally. And some water companies even do things like using sniffer dogs who are trained to smell chlorine.
Thank you. There is one final question talking about the new installation and also the maximum diameter that is possible using basically trenchless methods, and also the length that can be accommodated in new installations and no-dig solutions.
Well, there are a variety of methods that will go up to quite large diameters. We then get onto the very large diameter, we start moving into tunneling, which is we do the smaller tunneling in the ISTT, but not larger tunneling because there are plenty of tunneling societies out there. So you can go up to 1.5 meters, 2 meters or more, and probably when I say this, there will be a few people present who will suddenly put their hand up and say, "Oh no, we can do larger." But a lot of the technologies are for the more conventional diameters that we find that are used for different pipes. But particularly, say, large diameter sewer pipes with things like pipe jacking, we're looking at quite large diameters, moving on into essentially what becomes tunneling.
Okay, thank you very much. Here's another question from Jose talking about in hard rock formations, particularly granite massives, and considering existing wastewater and stormwater pipelines made of vitrified clay and reinforced concrete, we currently rely heavily on CIPP solutions, approximately 15 kilometers per year for rehabilitation. However, when capacity upgrades or diameter increases are required, this approach is no longer viable. In this context, which trenchless technologies are most suitable for the replacement or upsizing of such pipelines?
When it comes to that, we're probably, it depends on how big you're looking at and to whether we could do things like the pipe bursting to, if you like, you might have seen there were things like pipe slitting, pipe bursting. It is breaking the pipe and enlarging the hole. But I think you were talking there about granite situations or very hard rock, which is moving into the realms of some form of tunneling to enlarge the hole. So it depends upon the soil that you're working through as to whether you can enlarge and pull through something new, or whether you've actually got to consider something different, which might actually be having to put a new larger pipe in, because I'm guessing that one of the problems is keeping the service going whilst you are doing your upsizing.
There is one final question in the chat box asking basically if trenchless technologies can also be used to place vacuum sewer pipelines, which is not a straight line. Not sure if I understood that question correctly. Maybe it's referring to rehabilitation of sewer pipelines which are not straight but probably have bends in the root of the pipeline.
Can it be used to place vacuum sewer pipeline, which is not a straight line? There's a couple of elements to this. If you've got to have bends, then you might have to consider dig down, put the bend in, and then use the trenchless technology on the straight lines. Or it could be that you are able with a directional device to change the direction of the line that you are making. So it's interesting, when I was doing a project on rehabilitation of pressure sewers, and it was very clear there that on occasions it was necessary to dig down, sort out, particularly let's say we had two 45-degree bends close to each other right in the middle of a long line. We had to dig down and then treat it as two separate shots of a liner in either direction. So there will be locations where you need to dig, or it may be as well. Another thing you should always check. From my experience of doing research projects, we've had manufacturers who said, look, actually, you're expecting too much from our product. We can't fix damage like that. You've got to go in first and do a repair, or you've got to dig down and sort that out, because no trenchless technology or no sort of pull through or liner can really deal with that. So do think of potentially using a variety of techniques, including some dig down if necessary.
All right, I think this is it for the Q&A session. Thank you again, Ian, very much for your presentation. I think this will be shared or is available later on. Yeah, again, thank you so much for this presentation today, and thank you so much for your attendance.
Yes, thank you, Andreas and Ian, for a wonderful presentation. I guess all our participants, we can see in the chat that, they love the presentation and they would like to know more about, our future collaborations and engagements. So in that note, I would just like to quickly. Yes, so I think Ian is here, yeah. Thank you, Ian, for the presentation, and it was really effective. And I think we can already see in the chats that participants are already praising and appreciating, and they would love to know more about, future engagements with between ISTT and IWA. So I think we'll all keep you posted about the upcoming webinars and, specific topics that we'll have our knowledge and training sessions for. So thank you again, Andreas, for the wonderful moderation. And now coming to our upcoming events from IWA, I would like all the participants to explore our other webinars, including the one coming up on 3rd February. The title is Scaling Water Safety Plans to Fit Small and Under-Resourced Systems. And we have a huge panel lineup. So I would request everybody to check out this webinar as well. And then apart from that, we have another webinar on 25th February titled NBS Nature-Based Solutions in Coastal Environments. So I would request those who are interested in nature-based solutions can definitely check out this webinar. And I think that's a wrap from our side. And I would like to thank all the participants for their patience and for their attention and for their wonderful response and engagement with our speakers and the webinar panelists. And I think with that, we will wrap up this webinar and hope to see you soon again. Thank you, Ian. Thank you, Andreas.
Thank you.
Thank you.
Bye. Take care.